Hi guys, let's go over measures of variation. Let's just rock on in, eh? Alright, so let's get our pen out. We're gonna deal with some stuff. Alright, cool. So measures of variation. Basically, how do we measure the spread in the data that we're looking at? So let's begin with something you're familiar with. Let's begin with range. Well, what was that again? It was the the maximum minus the minimum. And in this case, that is equal to 5 meters minus 1 meter. 4 meters. This is the range of our values because our maximum height, Luke, who's 5 meters, and our smallest person, Susie, who's 1 meter, the difference between their heights is equal to 4 meters. And this is the range of our values. Cool. The next one here is our interquartile range. Interquartile range. So between, you can also denote it IQR, as you might see it often denoted in questions. Well, 25% of the values need to be smaller than something for Q1 and 75% bigger than Q2. So, and when we calculate this, we ignore, when we calculate this, we ignore, when we find out our Q1, we first ignore our median. So this here is Q2. So we're not gonna consider MAT for this. So our values are going to be this one, this one, this one, and this one. Well, we need a value that has 25% smaller values and 75% larger values. Well, let's go 1, 2, 3, 4, 1, 2, 3, 4. Well, if we increase by 1 and we decrease by 2, well, we have 2 larger values and 1 smaller one. This isn't quite right because we have a 1 to 2 and we need a 1 to 2 ratio and we need it to be 1 to 3. Because remember that 25% of data falls on this side and 75% of data falls on the right side of it. So we need to take our average. Well, 2 meters plus 1 meter divided by 2 is equal to 1.5 meters. So this is how we get our Q1 from the data is equal to 1.5 meters. Because if we have 1.5 meters, a value here, then we have one value this way and 3 values this way, Rach, Nick, and Luke. So that is a 75% change. That is 25% on one side and 75 on the other, or 1 on one side and 3 on the other in this case. Now we do the same for Q3. I won't bore you with the details, but Q3 will be the difference between Nick and Luke for the exact same reasons. So Q3, if you can work it out yourself, is the average between Nick and Luke, and that is equal to 4.5 meters. Well, our interquartile range is our Q3 minus our Q1, which is equal to our 4.5 meters minus 1.5. Well, you'll find that our interquartile range is equal to 3 meters. The value distance between our 75th percentile and our 25th percentile is 3 meters. And these are the measures of variation that don't involve any skew. It just takes the highest data and the lowest data at both of these points. Now let's look at the next one. Well, our next one is going to be standard deviation. I told you we'd go into this, and this one is going to be a bit tricky. So here is the formula for our standard deviation. So when you're dealing with a population, right? Oh, sorry, yeah. Let me just quickly. Here we go. When you're dealing with a population, when you're dealing with a sample. And I might need the space here, so I'm just going to get rid of some of this stuff. Because there's a lot to this. Well, a population is going to see the standard deviation as... It's like this. So 1 divided by n times the sum of all of the values x minus the average value of x, so the mean, and then you square this, and this is square rooted. And when you're dealing with a sample, it's very, very similar, but it's 1 divided by n minus 1. Oh, whoops, sorry, that's a little close. And then the same sum thereof. X, and remember, I denotes the index, average squared, right? So this seems quite complicated, but hopefully if you went over the reading algebraic notation, you'll understand how to get this. So let's look into this. Let's look into these values. We'll assume that this here. Actually, before I do this, let's see why. So if you remember earlier on, I mentioned that the standard deviation of a sample is always greater or equal to the population one. And why is that? Well, it's because the sample has this as the denominator for its fraction at the start. And what it does is means that this number here is going to be larger. When this number here is larger, it's going to make a larger number with this, and the square root of that is going to be larger than this. So this n minus 1 makes the overall number inside here greater than the overall number inside of here. And as such, you end up with a larger standard deviation. And this is to balance out the expected variation you might get from taking a sample, because taking a sample only gives you an inference about the population information. But what it doesn't do is give you a surefire picture of what the population is. And when you have population information, you know exactly what you're looking at. So let's work this out. We'll just do this for the population. So, well, 1 minus n. Well, how many do we have? 1, 2, 3, 4, 5. We have Susie, Rach, Matt, Nick, and Luke. Well, these are 5 people. So our n is 5. Now we're summing. Well, xi, or xi1 is going to be Susie, xi2 is going to be Rach, so on and so forth through the thing. So we need to go. We're gonna work these out. So x1, x2, x3, x4, and sorry about that. x4 and x5. That's a shitty 5. And these are equal to. Well, what is our average? It is 1 plus 2 plus 3 plus 4 plus 5 divided by 5. I'm not going to bore you, but that is equal to 3. So, 1 minus 3 is equal to negative 2. And 2 minus 3 is equal to negative 1. And 3 minus 3 is equal to 0. And 4 minus 3 and 5 minus 3 are equal to 1 and 2 respectively. Well, if we were to sum all these together, we would get 0. But what we're actually summing together is this value squared, because you notice that it has the exponent here for 2. So square these. Well, this here is going to be equal to 4 plus, well, because negative 2 squared is equal to 4. And if you don't, and then 1 for the negative 1. And well, 0 squared, that's equal to 0, because 0 times 0 is 0. Plus 1, 1 squared is 1, and 2 squared is 4. Well, and then we need to square root this. Well, let's, I'm just going to go like this. 1 divided by 5. What is the sum of this? Well, this is 5, 5, 6, and 10. So was it 5 and 10? Yep. So 1/5 times 10. So we're going to square this. So, this is equal to 10 over 5. Well, that's equal to the square root of 2. So we would say that the standard. I won't go into the decimal here because this will suffice as an answer. But the standard deviation for our population here is going to be equal to the square root of 2. And if you want to see that the sample standard deviation is going to be greater than this number, feel free to try it on your own. It's going to be very similar to this. These numbers should all be the same. It's literally going to be this denominator change. So instead of 5, this here will be a 4. And if you can figure that out in your head, you might know that 10 divided by 4, well, that would be the square root of 2.5. And the square root of 2.5 is a larger number than the square root of 2. Now, let's continue on with another thing. So there's a lot to that. You won't actually be quizzed on this, but I don't think it is reasonable for you not to have this information available, because part of the reasons you do this course, hopefully, is that you're interested in these subjects. And if you're not interested, why are you really here? So hopefully you'll be able to learn that. Okay, so let's go with the next one, variation. Well, oh sorry, not variation, variance. It's not for me to determine why you do a course, but that's just my thoughts on it. You can do whatever you want. Well, the variance is really simple. It's actually the standard deviation, standard dev, squared. So in this case, our variance would be the square root of 2 squared. Well, what's the square root of 2 squared? 2. So we would square it, and you could do it either way. So take the square root, which is 1.4 something, and then square that to get 2, or square 2, so the square root of 4, that's equal to 2. Well, the variance is equal to the standard deviation squared. And the final thing we have is something called, it doesn't come up too often, but it is pretty important. So we got the coefficient of variation. So what is the coefficient of variation? Is the ratio, ratio of the standard deviation to the mean. So in our case, it would be this. Standard deviation to the mean, which is, our mean was 3. Or you could write it as precise. Let me just quickly, I just don't want to get the I don't want to get the, what's it called, the numerator and the denominator wrong. Yeah, okay. So it is like that. So how we would look at this is you could also say this, 2 divided by 3. So the square root of 2 divided by 3 would be our population coefficient of variation. And what it does is represent a percentage to show what the variation in our data looks like. So normally you'd also go 100 times this, because it's representing a percentage.